Söz sizde. Siz nasıl isterseniz yönlendirebilirsiniz. Bir açılış konuşması yaparsanız iyi olur.
Okay. Welcome to the session 15 of 5th International Students Science Congress. My name is Murat Tuyan and I am from İzmir Democracy University, Department of Civil Engineering. And I'm going to host this session for you. This session has 5 presentations with different engineering topics. And before the presentations, I would like to remind you some points. Each presentation should take maximum 15 minutes, including questions, answers, and comments. Please take care not to exceed the duration of these presentations. In the last 5 minutes, I will warn you that you must finish your presentation. Now we can start with the first presentation. The title of this presentation is Rural Electrification with Solar-Powered Mini-Grids and Stand-Alone Solar System Installations, Case of Somalia. And when you are ready, you can start your presentation.
Hello, dear teachers. My name is Abdulaziz Hussein. I'm a graduate student at Erciyes University, Kayseri. Today, I'm here with you to present my paper, a conference paper titled Rural Electrification with Solar-Powered Mini-Grids and Stand-Alone Solar System Installations, Case of my country. If I start as an introduction, as we all know, let me check my presentation. Why is not doing? Yes, as we all know, in Africa and also in Somalia, access to electricity still remains a distant dream in many parts of sub-Saharan Africa, like in Somalia. In the energy sector, Somalia is one of the most underdeveloped in the region, especially in the rural areas. The rate of electrification is the lowest with a high cost of power for electricity generation. Somalia depends on imported petroleum products and cooking relies on biomass resources, such as in the case of the most African countries. The energy sector, and in particular infrastructure of the electricity in the country, is still underdeveloped. And we can say most of the people depend on biomass energy. In Somalia, according to a report, the population, only 16% of them has access to electricity, and those who have access to electricity is one of the highest in the whole world. The problem of our study is, as in other also in other countries, Somalia has a large number of remote small villages that lack electricity due to technical and financial limitations, and the possibility of connecting with the national grid in the future is highly unexpected. Recently, or present, these villages depend on energy generated from both diesel generator systems, which are very expensive. So we can say, to electrify the rural villages in our country, we can develop this system, solar-powered mini-grids and standalone solar systems. As methodology, as we all know, photovoltaic systems are appropriate when we are talking about rural electrification. So we use different methodologies to implement our study. First, we have go through a literature review on solar-powered mini-grids and standalone solar home systems applicable to rural households in different countries. BPSYST, the BP system software, are renewable electricity hybrid optimization model Homer algorithm are used to design the system. BPSYST and Homer scenarios have been developed and compared to select the structure of the techno-economic analysis of the system. The electricity requirement for a single house has been calculated, and the need for 100 households residing in the suitable location has also been estimated accordingly. Cost data for each of the power system components have been researched in detail from different websites and other publications. Our case study, as I have told, is concerned in Somalia. Initially, we select a target village, which is a less scale in our country. As you all know, Somalia is a self-rich. The relativity is self-rich as in Somalia gets an annual presentation, annual irradiance on average per year about 2,900 to 3,100 hours of sunlight, the total day radiation of Somalia. We can say that we can implement solar power systems in our country because of the country is full of rich with solar system or solar irradiance. This picture shows us the solar monthly radiation of the system. As we can say, in the whole year, the system of the solar system are the same, so we can use it. The average monthly radiation of the location shows the solar radiation is 3D.
Abdülaziz, internetinde sıkıntı mı var? Abdülaziz
Abdülaziz başlamış mıydı sunumunu?
başlamıştı hocam. Çıktı, geri gelecek herhalde, internete gitti.
Sıkıntı oldu herhalde. İnternet sıkıntısı var muhtemelen.
Evet. Geldi.
Alo, Kayır Bey. Beni izleyebilir misiniz?
İzin verdim, şu an paylaşabilirsin.
Evet, bilgisayarım gitti. Şu an telefondan bağlanıyorum. Burada devam edebilir miyim? Yani screen share yapmadan. Çünkü bilgisayarım şimdi kapatılmıştır. Yani teknik bir sorun var.
Sunum olmadan
Abdülaziz, sunumu paylaşamayacaksan senin şeyi erteleyelim. Sunumun yani oturumun sonunda
Tamam hocam. Şimdi bilgisayarım bir teknik bir sorun var.
tamam.
10
Bu
dakika.
arada başka bir arkadaşla devam edebiliriz. Murat Hocam hoş geldiniz. Bu arada Mehmet Çevik ben.
Merhabalar
Teşekkür
hocam,
ederiz.
hoş bulduk.
Online olunca böyle biraz sıkıntılar oluyor.
Evet,
İsterseniz
doğru.
sıradaki arkadaşla devam edelim. Abdülaziz bağlanabildiğinde.
Hande, burada mısın?
Evet, buradayım.
Müsait, sen de devam edelim o zaman. Sana yetki veriyorum şu anda.
Tamam. Kameramı açmama gerek var mı hocam?
İyi olur. Şimdi kimin
Sunumu
sunum
yapan
yaptığını
arkadaşlar
göstereyim.
açarsa iyi olur arkadaşlar.
Paylaşabilirsin sunumunu.
Tamam. Paylaştım. Şu an geliyor mu ekranım?
Geldi.
Tamam. Merhabalar, benim adım Hande Demiröz. Ege Üniversitesi Güneş Enerjisi Enstitüsü'nde yüksek lisans öğrencisiyim. Bugün sizlere fotovoltaik güç sistemlerinde maksimum güç noktası izleyicinin verimliliğinden bahsedeceğim. Genel olarak konu başlıklarında fotovoltaik sistemler, doğru akım dönüştürücüler, MPPT yöntemleri ve son olarak da yapmış olduğum uygulamadan ve sonuçlarımdan bahsedeceğim. Genel olarak baktığımızda günümüzde yenilenebilir enerji kaynaklarından en önemlisi olarak güneş enerjisi gözümüze çarpmaktadır. bu kaynak kullanılarak da fotovoltaik sistemlerde istenilen güç hesaplamaları doğrultusunda farklı sistemler tasarlanabilmektedir. Fotovoltaik sistemlerde kullanılan paneller doğru akım olarak gerilim üretmektedir. Bu gerilim istenildiği noktada gerek doğru akımla çalışan ekipmanlara, gerekse alternatif akım ile çalışan ekipmanlara transformatör kullanılarak enerji verebilmekte, beslenebilmektedir. Ancak fotovoltaik sistemlerin, bu sistemlerin bir dezavantajı, bir problem olarak görülen noktası elektrik enerjisinin uzak mesafelere aktarılması olarak günümüzde ön plana çıkıyor. Bu da daha çok kurulum maliyetinin yükselmesine sebep olmakta. Ve bu problemin ortadan kaldırılması için ise MPPT yani maksimum güç noktası izleyicisi sistemlerin, modüllerin tasarlanması başlanmıştır. Fotovoltaik sistemler güneş ışınlarını kullanarak elektrik üreten sistemler olarak tanımlanmaktadır. Bu sistemin en temel birimi güneş pilidir. Bunlar seri ve paralel bağlanarak istenilen güce getirilerek paneller ve diziler olarak günümüzde kullanılmaktadır. Fotovoltaik sistemlerin çıkışı lineer olmayan bir akım ve gerilim grafiğine sahiptir. Bunun sebebi ise üretilen elektrik enerjisinin güneşin mevsimsel olarak ve hava değişimiyle doğru orantılı olarak güneş ışının değerinin değişmesi olarak bilinmektedir. Bu noktada da bundan ötürü panellerden elde edilecek gücün maksimum olması sistem verimliliği açısından ciddi bir önem arz etmektedir. Burada da şekil 2'de bir fotovoltaik panelin akım ve gerilim eğrisini, şekil 3'te ise gerilim ve güç eğrisini görebilmekteyiz. Şekil 4'te ise bir panelin maksimum güç noktaları görülmekte. Aslında burada en önemli nokta panelin elektriksel olarak geniş bir çalışma aralığına sahip olduğunu görmemiz. Ama o noktada da panel gücünün maksimum olduğu noktaların sınırlı olması ise burada ayrıca bir önemli nokta olarak görülüyor. Genel olarak da baktığımızda fotovoltaik panelin üretmiş olduğu elektrik enerjisi direkt olarak ihtiyaç duyulan sisteme bağlandığında sadece maksimum güç noktalarında çalışabilecek noktalarda olmasıdır. Doğru akım dönüştürücüler doğru akıma sahip gerilim ve akımı hem yüksek hem de düşük düzeylerdeki akıma dönüştüren elektronik devreler olarak bilinmekte. Fotovoltaik sistemlerde MPPT modülleriyle kullanılan bu doğru akım dönüştürücüler panelden gelen elektrik enerjisini ihtiyaç olunan yani sisteme yüke aktarılmasını istenilen noktalarda sağlayan bir devre olarak rol almaktadır. Günümüzde dönüştürücüler farklı kullanım alanlarına göre çeşitlilik göstermekte. Bunlardan bazıları en çok günümüzde kullanılan olarak azaltan, yükselten olarak birçok çeşidi bulunmakta. Ben kendi uygulamamda azaltan dönüştürücüler üzerinde durdum. Azaltan dönüştürücüler giriş geriliminin çıkış geriliminden düşük olmasının istendiği alanlarda kullanılmakta. Dönüştürücü içerisinde kullanılan yarı iletken anahtar enerji girişiyle bobin arasında seri bir şekilde bağlanıyor. Bundan ötürü de giriş akımı süreksiz, bobin ve kapasitör yüke direkt olarak bağlı olduğu için ise çıkış akımı sürekli olmaktadır. Burada şekil 5'te de azaltan dönüştürücüye ait temel bir devre şeması görülmektedir. Azaltan dönüştürücüde kullanılan bobin iki farklı sürekli ve süreksiz olarak iki farklı modda çalışmakta. Sürekli akım modunda çalıştığında bobinden devamlı olarak akım geçmekte. Ancak süreksiz olarak çalıştığında ise bobin belirlenen periyot aralığında çalışmakta. Burada şekil 6'da görebildiğiniz gibi belirli bir periyot aralığı var. Periyot başladığı anda sıfır değerinden başlanarak yükseliyor. Ancak periyot sonuna gelmeden tekrardan değeri sıfırlanıyor ve o şekilde de periyot tamamlanmış oluyor. Maksimum güç noktası izleyicisi Fotovoltaik sistemlerde bunun kullanılmasının temel amacı panellerden elde edilebilecek olan enerjinin ve gücün maksimum olmasını sağlamak. Bunun şu noktada ayrıca bir önem arz ediyor. Fotovoltaik panellerde maksimum güç noktası farklı güneş ışınının değerlerine göre değişiklik göstermekte. Burada şekil 16'da aşağıda görebildiğiniz gibi farklı ışınım değerlerinde MPPT noktalarının nasıl değiştiğini görebiliyoruz. Maksimum güç noktası izleyicisinin, yani bu bir modül olarak geçiyor aslında teknik olarak. Farklı yöntemleri var. Bunlarsa sistem içerisinde kullanacak olan besleme gücünün, sistem gücünün yapısına göre çeşitlilik gösteriyor. Günümüzde ise en yaygın olarak aslında çok fazla çeşit var ama en yaygın olarak kullanılan değiştir ve gözle, artan iletkenlik, kısmi açık devre ve kısmi kısa devre akım yöntemleri olarak biliniyor. Ben de özellikle değiştir ve gözle yöntemi üstünde duracağım. Değiştir ve gözle yöntemi uygulanabilirliğinin kolay olması ve sonuçların anlaşılabilir olması açısından en çok kullanılan yöntemlerden biri. Burada bu yöntemde fotovoltaik panelin maksimum güç noktası akım ve gerilimin değiştirilerek sonucunun analiz edilmesiyle ortaya çıkıyor. Burada güçteki değişim en nihayetinde baz alınıyor. Eğer bir değişim yapıldığında değişim pozitifse sonraki değişim de pozitif olarak değerlendiriliyor. Eğer güçteki değişim negatifse bir sonraki adımsa negatif olarak tekrardan planlanmakta. Bu yöntemin tek bir dezavantajı bulunuyor. Aslında en büyük dezavantajı da diyebiliriz. Panelin anlık güneş ışınının değişimlerine maruz kaldığında doğru olmayan veriler üretmesi olarak biliniyor. Burada küçük bir örnek var. O burada kısaca anlatmak gerekirse sistem bir A noktasına ulaştığında pozitif olarak bir gücün değiştiği görülüyor. Ancak burada güneş ışınının bir parametre olarak değerlendirilmezse ve tekrar pozitif olarak uygulanırsa B noktasına düşebiliyor. Ki bu da istemeyeceğimiz ve yanlış olarak algılayacağımız bir gözlem. Eğer değerlendirirsek de C noktasında aslında bizim noktamızı tekrardan değerlendirmiş analizini yapmış oluyoruz. Bir diğer yöntem artan iletkenlik yöntemi. Bu yöntemde ise panelin güç ve gerilim grafiğindeki eğim analiz ediliyor. Eğer bu eğim türevi alınarak elde edilen bu eğimde eğer sıfırdan büyükse bizim belirlediğimiz maksimum güç noktasının solundan güç kise sağına doğru bir hareket ile değişimler gerçekleştiriliyor. Bir diğer yöntem ise kısmi açık devre gerilim yöntemi. Buradaki temel mantık panelin açık devre gerilimi ile maksimum güç noktasındaki gerilim arasındaki ilişki hesaplanıyor ve bir tabir parametresi ortaya çıkıyor. Bu parametreye bağlı olarak hesaplamalar yapılıyor. Son olarak da kısmi kısa devre akım yönteminde ise panelin kısa devre akımı ile maksimum güç noktasındaki akım arasındaki ilişki hesaplanıyor. Burada da K2 dediğimiz bir parametre çıkıyor ve ona göre hesaplamalar yapılıyor. Son olarak ben uygulamamda bir sistem tasarladım. Bu sistemde fotovoltaik panellerden oluşan sistemde 4 seri ve 2 paralel bağlanan toplam 8 panel 2 kW gücünde güç üretecek şekilde bir sistem kurdum. Sistem sıcaklığını 25 santigrat derecede sabitledim. Azaltan dönüştürücü devresi kullandım. Burada şemada görebilirsiniz. MPPT devresinin verimliliğini ölçebilmek için değiştir ve gözle yöntemini kullandım. Burada önemli olan öncelikle güneş ışınım değeriydi. Bunu 100 watt bölü metrekareden başlayarak 1000 watt bölü metrekareye.
The cooling valve had a big diameter.
Nasıl? Anlayamadım. Devam edeyim mi ben? Sesim geliyor mu?
Sesiniz geliyor. Devam edebilirsiniz. Son 5 dakikanız yalnız.
Tamamdır hocam.
5 dakikada toparlayabilirsiniz.
Tamam. 100 watt bölü metrekareden başlanıyor. 1000 watt metrekareye kadar arttırılıyor. Ancak ayrıca bir de 20 saniyelik bir analiz sürem var. O süre içerisinde 8. saniyede bu güneş ışınının değeri tekrar 500'e düşürülüyor ve tekrar 12. saniyede 1000 watt bölü metrekareye çıkartılıyor ki güneş ışınının değerinin aslında nasıl etkilediğini görebilmek için. Burada MPPT devresiyle kurulan sistemin devresi, şekil 22'de gösteriliyor. Şekil 23'te ise bu güneş ışınının değerine göre değişiklik gösteren panelin güç ve zaman grafiği gösterilmekte. Görebildiğiniz gibi 200'den başlayarak 2000 Watt'a kadar yükselen bir grafik var. 20 saniyelik analiz süresi içerisindeki gerilim grafiği şekil 24'te gösteriliyor. Şekil 25'te ise bu sistemin verimliliği gösterilmekte. Burada önemli olan nokta 100 watt bölü metrekaredeki güneş ışınımında verimlilik %97,5 olarak başlanıyor ve hesaplanıyor. Sonrasında 1000 watt bölü metrekareye genildiğinde ise bu değer %99'a kadar yükseliyor. MPPT'nin önemini net bir şekilde anlatabilmek için ben bu devreyi bir de panel sistemimi MPPT'siz olarak kurdum. Burada bu kurmuş olduğum sistemde ise güneş ışınım değerlerine göre sistemin güç ve zaman grafiği gösteriyor. Burada görebildiğiniz gibi ciddi bir dalgalanmayla başlıyor 100 civarında. Sonra maksimumsa 1200-1300 civarlarına geliyor ama stabil olarak devam ettiğinde 800 watt civarlarında kalıyor. 20 saniyelik analiz içerisinde sistem verimliliğine baktığımızda ise güneş ışınının değeri değiştiğinde 2 saniyeden daha uzun bir sürede ciddi bir salınım yapıyor. Bu da sistemin ne kadar kararsız bir yapıya sahip olduğunu gösteriyor. Elde ettiğim bulgulara bakacak olursak MPPT'li ve MPPT'siz olarak iki ayrı sistem kurdum ve bunların karşılaştırılmasında MPPT'li devrede maksimum gücün 2 kW'a kadar çıktığını görebiliyoruz. Ancak MPPT olmayan devrede ise maksimum gücün 800 Watt civarlarında olduğu görülüyor. Burada şekil 28'de daha net bir şekilde görebiliyoruz. Mavi olan çizgi MPPT'siz, kırmızı olan MPPT'li devre. Ve onun dışında da gerilim ve zaman grafikleri karşılaştırıldığında da MPPT'li olan, mavi olan 100 volt civarında başlayıp 120 volt civarına kadar yükseliyor. Diğer MPPT'siz devre ise ciddi bir dalgalanmaya sahip olarak ortalama 50 volt civarında devam ediyor. Sonuç olarak bu her iki sistem karşılaştırıldığında her iki devreden elde edilen gerilim biraz önce de bahsetmiş olduğum gibi burada aralarında yaklaşık olarak 80 volt civarında bir değişim var. Benzer şekilde söylemiş olduğum gibi güç ve zaman grafiğinde de yaklaşık olarak 1200 watt civarında bir farklılık olduğu gözleniyor. Ve en son olarak da en önemli noktası sistem verimliliğinde MPPT modülüne sahip sistemin ışınım değeri 97'lerden başlayıp 99'lara kadar yaklaşık olarak %3 oranında artıyor ve değişiyor ve sabit kalıyor. Ama MPPT olmayan sistemlerde ise minimum %2 ile maksimum %20 arasında ciddi oranda dalgalanma görülüyor ve bu da sistemin kararlı olmadığı ve sürekli olmadığını göstermekte. Beni dinlediğiniz için teşekkür ederim. Benim anlatacaklarım bu kadar.
Biz teşekkür ederiz sunumunuz için, katkılarınız için. Soru var mı? Kısa bir soru alabilirim. Bir dakikalık bir süremiz var. Katılımcılardan sorusu olan varsa soru alabilirim.
Ekran paylaşımını durdurabilirim isterseniz.
Soru yok herhalde. Durdurabilirsiniz. Teşekkür ederiz tekrardan.
Ben teşekkür ederim.
Okay, now we can start with the third presentation, and the title of this presentation is a review of blade number and rotor size effects on multi-bladed windmills, prepared by Omar Abdulkarim Kasım and Ahmet Samancı.
Yes, sir, I am here. I can hear you.
Okay.
Can I share my screen?
Yes, you can share your screen.
Okay, thank you.
When you are ready, you might start your presentation.
I'm ready. Good afternoon to everybody. My name is Umar Abdulkarim Kasım. I am an international student in Necmettin Erbakan University, Energy System Engineering Department. Today I have a presentation under the title of a review about the effect of solidity and number of blades. Sir, I have a problem in my screen. Can I fix it 1 minute?
Sure.
Tekrar paylaşabilirsin.
Sir, I have a problem with sharing my screen. I don't know what's the situation here.
Can you try share again?
I'm clicking on it, but it's not sharing. I don't know what's the problem. Sir, can you see my screen?
Yes, we can see. You can continue your presentation.
Okay. Sir, I have a problem in my screen. I don't know what's it.
Bu ekrandan devam et.
I'm sorry for being late. Good afternoon to everybody. My name is Umar Abdul Karim Qasim. I am an international student in Najmuddin Erbakan University, Energy System Engineering Department. Today, I am here to present my seminar under a title of a review about the effect of solidity and rotor size on the efficiency of the windmills, under supervision of Professor Dr. Ahmed Samanji. This is a list of contents of my presentation. Abstract. As we all know, the rising in the fossil fuel prices leads the world to focus on new, cheaper, and more environmental, sustainable, renewable energy sources. And we all know that the wind energy has been realized as the most of the essential form of renewable energy, and it can be used in different applications. One of these is windmills or wind pumps. In this presentation, we have a literature review based on the previous studies which presents the basic design parameters for windmill rotors. Also, the investigation of this seminar is based on the number of blades and rotor size effects on the main performance of the windmills. As a definition of windmills, we all know that a windmill is a structure or a device that converts the wind energy into rotational or mechanical energy by means of blades. This term of windmills can be extended to wind pumps and wind turbines and other applications. The development of windmills. In recent years, significant effort was made in construction of new types of wind pumps. As we all know that all windmills could catch only up to 30% of the wind energy, but the new ones can catch up to 40% rating. The image below shows the sequence of the windmills development since that time. The types of the windmill nowadays. In general, windmills or wind turbines are classified into two types, according to the axis of blades, horizontal wise and vertical windmills. Components of a horizontal windmill. If we looked at this schematic drawing, we have a horizontal axis windmill which is attached by wind water pumping systems. First, we start at the windmill's components. First thing is the blades. Most turbines have either 2 or 3 or more blades. Wind blowing over the blades causes the blades to rotate. The second thing is the gearbox. This part can convert the kinetic energy of the wind to the mechanical energy. The third part is rotor. Rotors consist of the hub and the blades together. Finally, the final part of it is the tower. The towers are made from the tubular steel, as shown, or concrete. Because the wind speed increases with the height, taller towers enable wind turbines to capture more energy and generate more electricity. The parameters of the windmill's efficiency. Significant factor can involve in determination of the windmill efficiency, which are the number of blades that impact on the significance of power and design of the tip-speed ratio. These parameters are: first, the number of blades; second, the rotor diameter of rotor; third, tip-speed ratio; and finally, material selection. First thing, the effect of the solidity and the blade number. We can define the solidity as ratio between the actual blade areas to the swept area of the rotor. Also, high solidity makes the rotor starting easy due to increasing the interaction areas with the wind. Increased solidity can also increase the torque for given rotational speed, thus increase the power output, solidity, and blade number can affect on the following factors such as torque and tip speed ratio and coefficient of power. Kentfeld described that high solidity windmills produce much more torque to the modern ones. Proctor and Weiser tested a 6-bladed design on an open site and demonstrated that the increased blade numbers potentially give the advantage of low rotor speed variations due to turbulent wind flow conditions. Lockwood tested as effect of solidity and the blade numbers on the efficiency of rotor. They tested separate rotors with constant diameter. They found that raising the number of the blades from 3 to 12 while retaining the constant strength of 10% decreases the aerodynamic efficiency and power, as we said, due to the Reynolds numbers effects. Also, wind tunnel blockage impacted results. If we examine this figure, we can see that the increased blades number from 6 to 12 can decrease the overall maximum power coefficient. ISSC used a 16-bladed rotor model in his numerical investigation, which designed on solid edge as shown in the following figure. The radial length of each blade and rotor diameter were 1.2 meter to 3 meter respectively. He tested a model at different wind speeds, and this result was given estimated for the wind speed 3.5 meter per second. And the result shows that for windmill having 3 meter diameter can deliver us 0.95 cubic meter per hour of water. John tested 3, 6, 12, and 24 bladed models of windmill with a constant diameter of 0.68. The study indicated that high blockage and large effect on rotor output. If we examine this table, we can see that increasing the number of blades from 3 to 24 could increase the power coefficient, but at the same time, the value of lambda is decreased. Kiosinta tested a windmill model with a 12 blade and 1 meter diameter. A comparison between mathematical and experimental results was made and shown in the following figure. The maximum power coefficient is approximately 0.296 at the rate of the tip speed of 1.18. If we examine this figure, we can see that the power coefficient of the windmill is decreasing with increasing the tip speed ratio. Finally, we can describe the relationship between the solidity and the number of blades as the following equations. Solidity, that is a dimensionless quantity as we know all. Solidity equals the number of blades multiplied by area of one blade divided by swept area. Swept area is area which the rotor blades spin as seen when directly facing the center of the rotor blades. The effect of the diameter of rotor. The scale of windmill rotor, which is in use in the percent range between 2 and 10 meters in diameter. The particle wind for particle multiplied times. The large size of windmill rotors, diameter about 10, is usually used for sprinkler irrigation and is coupled to centrifugal pumps, but the smaller ones can be used for small farm irrigations, domestic water supply and watering livestock, and it can be coupled to the piston pumps. As we all know, increasing rotor size could give us a better performance, but we must take in account at the same time the increase in the cost as well increase in the weight. Through our review of previous studies, which is summarized in this table, can be shown. If we examine this table carefully, we see that we can estimate that the diameter of the rotor generally ranges between 1 to 10 meters, and wind speeds can be ranged between 2 into 5 meters per second. So we can say that windmills can be used in low wind speeds, and also they can be fabricated with low costs.
Sorry.
Fine.
5 minutes to finish the presentation.
Okay, sir, thank you. The effect of the diameter of rotor. Finally, we can summarize this relationship as in the showing equation. If we examine this equation, we can see that torque is related proportionally to the diameter of rotor. Finally, we have look at the effect of the tip speed ratio. Tip speed ratio is the ratio of the blade tip's velocity at the radius r to the wind speed velocity, and it's numerically can represented as shown in this equation. The relationships above shows that when the value of tip speed ratio lambda is equal to 0, this means the windmill is stationary and not moving. Also, when the value of lambda equals to 1, this means the blade tips are moving at the same speed of the wind. And this means that efficiency of the turbine reached the maximum value. According to Laguerre, relationship between lambda and power coefficient shown for classic American multi-bladed windmill. If we examine this figure, we can see that value of CB reached the maximum when the lambda is equal to 1. But these values may be improved or developed by changing the design of rotor, as ISSC calculated the relationship between the power coefficient and the tip speed ratio for his 16-bladed model and compared the result with the last ones. If the tip speed ratio is high, it requires short coral length, which decreases the dimensions of the blade and the material used. That means it decreases the cost. Piston pumps operated at high torque values. We can also reach this by decreasing the value of lambda. Finally, we can show the comparison between different design parameters turbines that operate at low and high lambda values. Selection of materials. This parameter can also make an effect on the cost of the fabrication. The most common materials used in manufacturing windmills or rotors are wood, aluminum, and molded plastic. As we all know that wood is simple to work, easy feasible, and also aluminum alloys have good mechanical properties, but they require special equipment and tooling. Also, molded plastics have a lightweight and good formability. If we examine this table that describes the comparison between properties of some materials for manufacturing windmill rotors, we can see that most common materials are aluminum extrusions, molded plastic, and wood. Calculation. Finally, from our literature review, we can say that wind energy and windmill for water pumping technologies are the best. We estimated that using the green energy has more benefits than the other fossil types, starting from economic advantage and taking into account the decreasing of the gas emissions. The most important notes and the most important result of our study can be summarized as the follows. First thing, the wind pumps can perform well at low wind speeds. The second thing, that when the tip speed ratio is equal to 1, the performance of the wind turbine are equal to the highest or the maximum value. Third thing is, when in the order to get higher starting torque, the windmill must have a high solidity and low tip speed ratio, and this can be reached by increasing the number of blades. Fourth thing is, increasing the number of blades decrease the aerodynamic efficiency, as we said. And the fifth thing is, at the high wind speeds, wind pumps can give a high mechanical and water flow, but the overall efficiency decreases. Finally, increases the solidity decreases the lift, but increases the lift to drag ratio. These following slides are the references that I used in my seminar. Thank you all for listening. If you have any question, I am ready.
Ömer, kameranı açabilir misin? Ben yazıyorum ama sen açmıyorsun.
Ömer, can you start your camera, please?
1 minute, sir.
Thank you.
Sir, I'm sorry, I was having a problem with my laptop and it wasn't reaching the camera. I don't know what's the problem. I'm so sorry for it.
No worries. Congratulations. Thank you so much for your presentation.
I'm thanking you for listening for me. Thanks.
Is there any question or comments for this presentation?
May I ask you a question, please?
Sure.
Of course.
Ömer, can you go to the last slide, please? Conclusion.
Okay, I'm going.
I
This
want
one
to ask
or the
question,
second
yes.
one?
Yes.
This one? Okay, thank you.
Maybe I missed because I cannot stay thoroughly through the presentations. I'm going from one hall to the other.
Okay.
The last conclusion, increasing solidity decreases the
Yes.
lift. You say,
Yes.
what's solidity? What do you mean by solidity?
Solidity means the ratio of the area of one blade divided by the area of the sweep of the rotor. Also, we can say that solidity means the number of blades of the rotor at home.
Then a question.
Yes.
For an area of total area of blades,
Yes.
should I use 3 or 5? Or does it matter?
You
Total
can,
blade area is the same.
yes, yes, sir, I understand you. Look, we can use the 3 or 5 models of different shapes of the blade. And we can also change the solidity ratio by increasing area of one blade to the area of sweep.
For a constant solidity blade ratio.
Okay.
Blade ratio is constant.
Yes, solidity is
number
constant.
of blades, 3 or 5.
Yes, we can use it, and we can reach more results. Or maybe we may change the shape of the one blade and decrease or increase the number of blades. It does not matter.
I think it's accepted that 3 blades is the most efficient until now.
Yes, sir. In the electric generation wind turbines, as we see in the most countries, it is accepted for 3 blades. But these 3-bladed wind turbines are so difficult to fabricate, as we all know, and these blades have high aerodynamical efficiency, and this requires a very, very high cost and very, very difficult composite materials to build it. But if you use it a normal or a simple windmill type for water pumping system in the farm or in the village, we cannot, we cannot fabricate that. That's cost of them. Of course, we must make a simplest design to reach our goal, which is the only raising the torque value.
Okay. Thank you.
Thank you, and thank you.
Murat Hocam, mikrofonunuz kapalı. Duymuyoruz sizi.
Sorry. Thank you so much. For now we are going on the 4th presentation, and it's about the investigation of the thermochemical heat storage system for domestic application, a review prepared by Sarah Walid Abdul Sattar, Omar Abdul Kerim Kasim, and Ahmet Samancı.
Hi, sir. Can I share my seminar?
Yes, you can share your screen. And whenever you are ready, you may
Okay,
start.
Sarayı
Okay, sir.
co-host yapabilir mi? Ha, yaptık, tamam. Sarah, can you start your camera also?
Yes, sir. Can you see me, sir?
Okay.
So can you share the seminar?
Yes, we can see.
Okay. Firstly, I would thank you to organization this congress. Our paper is about investigation of thermochemical heat storage for domestic application, a review that prepared by me, Sarwad Abdustar and Omar Abdul Karim Qasim with Ahmed Samanji from Najmuddin Erbakan University, Energy System Engineering Department. In the content, we have abstract, we started by the introduction and then thermochemical storage with the thermochemical storage material, cost analysis, and conclusion with the reference. In the abstract, we know that in many parts of the world, the solar radiation is thought to be one of the most likely source energy. Scientists and research know and new and renewable energy sources all over the world. Developing energy storage devices are important as researching new energy sources. The storage of the energy in the appropriating from and converting this stored energy into the traditional decided format has been the currently challenges of the technology export. Energy stored not only reduce the mistake between the supply and the demand, but also improving the performance, reliability, and energy conversion of energy system. In our paper, the different energy storage system, the different energy storage material concepts are reviewed, and the heat storage material are classified. The study concentration to three important conditions: charging temperature, energy density, and the cost analysis for choosing the best thermochemical material that could be able to seasonal for using its seasonality in the domestic application. Based on this additional analyzing with the use of the concentrate, the magnesium sulfate hydrated is determined to be the most material that can we use it for the application for the domestic application, because it have higher energy density with the lower cost, as well as it is charging temperature nearly to the 100. It's really easy. We're starting with the thermochemical energy staging, which is advanced the energy technology that has recently attracted increasing interesting for thermal applications such as for water heating, cooling, and air condensation. The thermal energy system have enormous potential and facilitated more effective use of thermal equipment and larger scale of energy substitution that are economic. The thermal energy storage, a person that's not important only for the mistake between the supply and demand of the energy. In this picture, we show that in the summer season, the thermal collector, which be containing the thermochemical material, will be sending or transferred to the reactor energy stored, and then we treatment it by the catalyst for using it for domestic heating in the water seasonal. The energy storage can be divided into three types. We have thermochemical energy storage, latent thermal energy storage, and sensible thermal energy storage. Sensible energy storage system can be stored energy by increasing the temperature of the stored material without changing any without changing for the phase traditional in material, but in the latent thermal energy storage, the material will be changed the phasing from one form to the another form, like from solid form to liquid form and liquid form to the gas form with constant temperature. In the thermal chemical energy storage involving some like of the reversible exotherm and endothermal reaction with a thermochemical material. In this method, we have a higher storage capacity and higher energy density than the other. The benefit of the energy storage can be give us a better economies like reducing the capital and operation cost, the better efficiency, achieving more efficiency use of the energy, the less pollution, better system performance and reliability, and we can use it for project balance thermal and electrical output. We can use it for the long term and the short term for the cooling and can recover nearly 99% of the stored cooling. The thermal energy storage, thermochemical energy storage. In thermochemical energy storage, as we say, typically it is stored in the form of the bound energy of the reversible chemical reaction involving one or more chemical components as the storage material. Generally, this operation can be taken in three parts: the charging temperature, which is the endothermal reaction, and the storing process, and the discharging process, which is the exothermic process. The principle of the thermochemical energy storage, as we show from the form is the reversible reaction. The storage will be taken by breaking down the component molecular, and then the energy will be released by combining the broken down. In the summer, the component C will be decomposed by using the catalyst into the A and the B component by the solar heating at the charging temperature, which will be higher than the discharging temperature, and material A can be stored until the winter. In the winter, material A and B will be mixed together and starting to the reversible reaction. The temperature will be lower than the discharging temperature. We can the product from this reaction can be used for the domestic application. Here we show in this table, we show the operating state from the charging and discharging temperature. Like in charging temperature, the iron will be heated in the solar collector in temperature between 18 and 1000, but in discharging temperature, in discharging process, the iron will be heated between 20 to 25 Celsius. In charging temperature, the hot dry will be entered to the system, but in discharging temperature, the humidity air will be entered the system. In charging temperature, the exhausted air is released to the inbind, but in discharging, it will be transferred by the fan cooling to the building, and then the air will be returned back to the collector, and the cycle will be complete. Traditional, we have two types of the thermochemical energy system: open system and closed system. Shortly, in open system, the fluid in the gas state will be released to the environment directly, but in closed system, no fluid is shared with the atmosphere, and the working fluid is not be immediately released, but it will be raised by using the heat exchanger, as we show in the figure. Energy density. Energy density is the one of the important factor that we effective to the material that we can use it in the thermochemical energy storage. For the closed system, the energy density of the material should be similar to the 3 gigajoule per cubic meter, but in open system it will be similar to the 1.8. In the figure, we have shown the different type of the thermochemical energy storage, and we show that we noted that the thermochemical energy storage have the high energy density than the other, and can give us the more of the energy than the other type. Here we have the thermochemical energy storage material. Before we choose any material for thermochemical energy storage, we should take into account some of the parameters like the cost, like the availability, toasting and safety of the material, corresponding savings, energy storage density, reaction temperature, the heat transfer coefficient, heat transfer fluid, the good thermal and chemical stability under the operation condition, temperature picture, and the material should be environmentally friendly. The characteristics of the material that we use it in this system, which must be high energy storage density, high and uptake of the solvent. It will have a good heat and mass transfer property to ensure designing outer power. It will be handily non-toxic, low costing, and suitable for application. The higher surface area will be a good mechanical strength and the stability. The lower regeneration temperature, which is meaning for the charging temperature lower than 113 Celsius. The type of the absorption chemical, thermochemical storage material. The thermochemical storage material can be categorized into four important categories: the solid adsorption, liquid absorption, composite material, and chemical reaction. The solid adsorption. The solid adsorption in this process, the reaction typically will be exothermic reaction, which adsorption will in this process the molecular would be enhanced in the surface of the material. In this table, we show the almost material that can use it in the solid adsorption, and we show the charging temperature with their cost. Except one material, we show that almost of the material have the charging temperature more than 100 Celsius. The liquid absorption. Liquid absorption is a chemical, as we know, is a chemical and physical phenomenon. The liquid absorption penetrates into the surface of the layers of the solvent, entering the structure of the solvent, and result in change its composition. In this figure, also we show almost the component that we can use it as a liquid absorption, and we show their energy density, their charging temperature, and their cost. We noted that the K2CO4 and the Na2S have the higher energy density between 1.3 and 2.9079, and their charging process, their charging temperature is almost of them is lower than 100 or between nearly to 100 Celsius. In the composite material in this process, we mixed the salt with the matrix, host matrix. Host matrix is critical and prevents solid agglomeration and swelling, which contributes to improve moisture diffusion during the heat regeneration. We have all here in the table 2, we show the hosting material like activated carbon, silica gel, zeolite that can be mixed with the salt like chloride, chlorium chloride, and magnesium solvent.
Sorry, you have 2 minutes left.
Yes, sir, thank you. Chemical reaction. In chemical reaction, a large amount of the salt hydrate will be mixed with the water into a crystal lattice. In the summer, the hydrate solid will be heated and crystal water will be driven off. In long term of the seasonal storage system, the solar heat can be implanted to the dehydrate, and then anhydrous salt will be stored. In the winter, the salt undergoes a reversible reaction. The energy product from this reaction can be used for the heating water or central heating. In this in this figure, we showing the characteristic of the chemical reaction material. We show that we show their charging temperature and the energy density with their cost. We noted that almost of the material have the high energy density, like magnesium solvent pentahydrate and the sodium sulfate pentahydrate have the energy density nearly to 3 by 2.8, and their charging temperature were nearly to 130. In cost analysis, when we cost analyze, we not just cost analyzing the cost of the material, but also their transportation, their storage, and their energy requirement of charging and discharging the storage material, and all the price that given in this paper will be given by dollar by kilogram. In conclusion, the primary goal of this research is to discover the chemical reaction that can be used to store the energy. And finally, we choose that the magnesium chloride and the calcium chloride dehydration will be selected as be the best charging temperature condition, and the magnesium sulfate pentahydrated and the sodium sulfate pentahydrated will be chosen to be the higher energy density. The magnesium sulfate hydrate pentahydrate will be choosing as the minimal of the cost. Finally, we choose the magnesium sulfate pentahydrate as the best material that we can use it for the domestic application, because it is have the energy density about 2.8 kilojoule per cubic meter, and it have the energy, the charging temperature was nearly 100 Celsius. And thank you for listening. Here we have the reference of the seminar.
Thank you so much for your presentation.
Thank you,
Congratulations.
sir. Thank you, sir.
Is there any
Stop
question
sharing?
or comments for this presentation? Actually, there's no question. And thank you so much.
Thank you, sir.
Now we are going on the 5th presentation. The title of this presentation is Hydrogeological Studies of Aliya Oil Refinery and Surrounding Area, İzmir, Western Anatolia, prepared by Abdülhafiz Sayed and Gültekin Tancar.
Good afternoon, everyone. Yeah, hi. Good afternoon.
Good afternoon.
Yeah, my name is Abdülhafiz Sayed. I'm from India. This is my presentation and research work in Turkey, which is I'm carrying out from last 1 year. So I'll be sharing you with my presentation.
You can share.
Yeah.
Yeah. This is my topic of presentation: hydrogeological studies of Aliya Oil Refinery and its surrounding area in Western Anatolia. As you all know, my name is Abdülhafiz Sayed, a research scholar from Doğu Eylül University, and my professor, Dr. Gültekin Tarcan, the geological professor. As you all know, the Aliya is in Western Anatolia, the oldest rock unit, which is İzmir fly ash. It is a Cretaceous deposit, the oldest region of the rock. And it is like lower in the age, the Miocene period, which is consist of volcanic rocks that are agglomerate, tuff, marls, and conglomerate, etc. And this Turkey, you know, it's a very geothermal potential. Turkey is having a big potential. They are producing the energy from the electricity through geothermal energy. So this area has a great importance, Aliya region, because there is a petchem area As you can see in the introduction, the geological area, geographical locations, it is surrounded by Dumanli Mountains, Yunt Mountains in northeast and Aegean Sea to the west. And it's the biggest industrial area, Alia. After 1970, it's from a small agricultural land. They started it developing within the 20s. From 1970, they make it as a good industrial area. Alia region developed due to its petchem, the refinery establishment, as you can see here, and its accessibility means it is near to the port. The transportation facilities easier, the factories development is possible, and due to its geographical location, it's very economical, the Alia region. So it become one of the good economic point of view for the region of Turkey in Izmir. So it's having the various furnaces, steel factories, and industrial sectors from north to south with Chanderlane, Alia, Nemrut Bay, harbor and pier facilities, the sea transportation, economical, culture and data and geographical facilities. So my aims and objectives of this presentation, it's on the geothermal potential and the groundwater pollution, which is due to the refinery and the region, as the oil is there and many industrial areas there, so it will contaminate the water, the groundwater resources. What is the relation with the groundwater? What is the relation with the geothermal water and the interconnected water with the geothermal water and the groundwater table? So it's up to this things, and the pollution which is happening with the seawater, which we call seawater intrusion. So seawater which is coming due to the low level of water level in the Alia region, the seawater is intruding into the pure drinking water, which is our groundwater resources. So we are checking with it the contamination of water. It's a research project, so we are dealing with this, with the pollution process, and there is a numerical equation which can determine as in this slide which I'm explaining. There are two hot springs in Alia districts known as Bichar Spa, which is located at north. They are having a good temperature, 36 degree, and the speed of the water flow is from 30 liters per second, which we can draw from Koch et al. And in from 1967. And similarly, there are water sources like Alia Sahil, Iljalari, Iljaburun Thermal Spring. On the other hand, emerges from northwest side. So these are the geothermal potential streams which are near to the study region. So with that aspect, with the correlation with the two regions, Alia Sahil, Iljalari and Iljaburun Thermal Spring, so it is determined that it is also having a good potential of the geothermal potential. It's having a good potential through it. And there is a tectonic elements, tectonic activities there. There are many faults in Izmir. It's happening nowadays daily due to the tectonic events, like from northeast to southwest. Recently, there was an indication of tsunami in Izmir from last 4 months back, 4 to 5 months back. So it's a very tectonic prone area, Izmir region. Then Alia, it's due to its tectonic activities, the faults are there, the horse graben structure is there. It's very structurally variations is there. Like we are getting different types of rocks, limestone, silicified limestone, marl, volcanic stuff, andesite, which are Neogene age, which are oldest, and quaternary age. And the Alia people are getting their water from this kind of wells, like drinking waters from the artesian wells. And the flow of direction is from south to north, which is from Nemrut Bay to the Aegean Sea. This is our geographical. See, this is the study region of Alia, which is a Google Pro map. The area of region where I'm studying, it's basically Alia oil refinery, Tuprash. So Petkim, I'm just researching around its surrounding area. So it is indicated. Now, this is a small introduction of geological region, that is identification of rock units by Esder et al. In 1994 in his studies. So I can from MTA, the MTA region research which carried out. So this is a graph which shows the different geological symbol of different agglomerates, andesite, rhyolite, dacite, Chamda limestone, Alia pyroclastic, Soma formations. This is the generalized geological area of the field, Alia region in Izmir. So this the cross section, I made it as per my as per the research and the study work material from Upper Cretaceous to the present Quaternary alluvium. So it is from Izmir fly ash, Soma, pyroclast, Chamda limestone, Hatundare dacite, Saralkaya rhyolite, agglomerate, Dumanlida andesites. So it is different volcanic rocks, metamorphic rocks, which are included, which are intercalated It is briefly explained here. From green schist facies, clastic sedimentary, pyroclastics colored. It depends upon the different lithological events happen with the time. It's not a small time of gap. It's a million years of gap from upper Cretaceous to lower, middle, and upper in Miocene age. Then Quaternary alluvium, which is the present, which we are getting the eroded alluvium soil in this region. So this is the map showing Miocene stratigraphy of Soma Aksar region by Donmez et al. It's from Alia formation. As you can see on the left side, it is Dumanli group. The Alia is overlying above Dumanli group. Then Focha tuff is there, Soma group is there, Altin Tepe volcanic rocks is there. So it is a lithological studies, a cross section. When we drill, as you know, when we drill the bore well down, we are drilling like maybe around 30 to 50 feet into the region. As we take that cross section, we can find this region very well. So this is the region, and the generalized map, geological information which I explain you right now, upper Cretaceous to allochthonous positions. The rocks which are allochthonous means the rocks which are getting deposited, not at the same position, which is getting transported, and at the base it is getting deposited. So Izmir, like the Alia, the formation of alluvium, it's a great amount of depositions of rocks, a great amount of basin formations there. So same, it is explained the rock formations, colored gray limestone, mudstone, sandstone, siltstones, fine limestone in the upper parts, which I explained in the cross section area. These are the common unit. Alia pyroclastics, the main important, it is in the middle of Miocene, the land, and was sometimes covered by shallow water, little depth. These were andesite lavas and pyroclastics forms. So these are the lithological variations. Alia pyroclastics, which are weathered tuff pyroclastic rocks such as pyroxene, andesites. These are different rocks, and they are different rock minerals. In the area pyroclastic we can find. Same Chamda limestone. As per you know the name, it's a limestone formation which is from the lower Miocene Soma formation. Means at what formation, what age that rock has been formed. So in from upper Miocene to lower Miocene. So it is a phase of deposition of Chamda limestone. So this is explained here. Then Alia volcanics is there, which is of middle Miocene to Alia pyroclastic age. So short form is TAP, name as Alia volcanics. So it is from upper Miocene, sialic in origin, like it is having silica and aluminum content, which are mapped from the bottom to top as Hatundare dacites. It's igneous rocks. So and then Bosdiel basaltic rocks, all are igneous igneous rocks, variations, Dumanlidite, andesites, which has been studied by Ejder et al. In 1994 in his introduction studies. So this is the same Hatundare dacite, the lithologic variations which I show in the cross section. So Hatundare, then Sarilka rhyolites. Just going forward, it's the same thing. Bosdiolite basaltic andesites. It's a volcanic rock. Then above it is agglomerate, which is TAGL indication. Same study by Ejder et al. 1994 near the exit center. Dumanlide andesites. It is the same lava flows emerging from certain crevices. The faults and are there. We can find Dumanlide andesite rocks and the aluminum, which cover the large area, central part. It is still continues. These rocks, it consists of recent aluminum, which forms the valley basis fans. As we can see in the deposition, which is forming the basins, the fans are forming. It consists of pebbles, blocks carried by aluminum fans, and etc. Then materials and methods. So what we are basically doing in these studies, the laboratorical studies, we are making the field maps, coordinates with it. We will take the GPS reading. Then we will do the pH of the water on the field region. Then we will take the electrical conductivity. Then we check the salinity of water with the help of the multimeter. We are having a multimeter device. So me and my Hojam, like my teacher, Professor Gultegin Tarjan, with me, and one of my colleague from university, Anil Kuchuk Sumbol, assistant professor from Doku Zelul. We together, we are going at the field, taking the samples in the bottle for 50 ml to 500 ml plastic bottles. So with the multimeter on field, we are taking the reading of salinity, electrical conductivity, the temperature of the water, then pH, and we store that water in our refrigerator at the prescribed temperature, at the temperature which it will not affect the water characteristics. So and
Sorry,
in this will, yeah.
You have 4 minutes left.
Yeah. No, my presentation is the last one. That's why.
Okay.
So chemical analysis will be evaluated with the help of Aquacam software. Is there one of the good software, Freaksy program? Then we will construct, as you can from the hydrogeological books, you can all get this thing. Like paper diagram is there, where we can mark the water as a good water, contaminated water, highly saline water, and with the there is one more Scholar diagram, scholars diagram we called it. So with that also we can determine the quality, this one, salinity of water as per the conductivity, we can determine it. And mineral saturation index with the different watch program is there. We are trying to do with it. Then we can determine the reservoir temperature with the software dealing with this. Then we are determining the temperature mineral equilibrium with this graphs. Like with the watch program, we can assume the temperature of different reservoir in from where we collected the water. So we can show the geothermal potential also. And with this, in Alia region, is this water a good quality water? Like drinking water quality is good. It's go from 6.5 to 9.5. Will the parameters are set by UNO, like United Standards, European Standard, and Turkish standards are there. So with this, the number of mineral contents in the water in that region, we'll be determining that through this research work, which will be carried out within this year. And at the same times, we'll see the water is contaminated for the people of Izmir, for the people of Alia. It is very important project, and for the government related to, because it's a refinery, it's the reason the pollution is there. So we are searching for that also. So this is a standard pattern, Turkish standard, European standard for different elements to be present in water. So with this, we research out this numerical values as per the standard from Geological Journal of Geological Engineering 44 2/20. It's a different element contains in it. Then the chemical parameter, because these are the harmful element, arsenic, beryllium, strontium, lithium, all are. So what microgram per liter it's present in that water. So we have to research by cation and analysis in the lab. We'll carry out this thing. And the different lead, this chemical analysis same. As you can see, my teacher names are there, Tarjan et al, Gemiji. So they have proposed this standard by doing the research in different region, in different areas of Turkey. So they have put these standards for waters in their journals, in the scientific journals, which we can see from this graph. And seawater intrusion, the main thing is this one, the formula which I calculated for this, for the FC, the CCl sample of the water and the chloride in drinking water. So the chlorine content is very important to determine the water quantity. It's very important. It's very important, the chlorine content in the water, to determine its age and how much it is efficient for drinking. Because if seawaters get intruded with the mineral water, in seawater there is NaCl, sodium chloride. The chlorine content will increase in our drinking water. So we can check without that did seawater intrusion is been with our water or not. The water is contaminated or not. With this formula, we discovered this formula by searching various journal, and we can prove this formula with the respective samples. We'll take it from the field studies. Is it okay? I cannot move my slide. Can you hear me?
Yes, I can hear you.
Okay. Yes. So this is the same thing. So with this, the result, with this my study, we will do the literature studies, what I carried out, physiographic, stratigraphy, petrography, and methods to be applied are studied in this thing. Then chemical analysis, major ions, which standard studied. Then relevant standard for drinking water, we can carry it out. Analysis method to be determined, what analysis we are carrying out. Seawater intrusion with river water, it will be specified with this equation, which equation I show you. Then seawater theoretical percentage, interference with chloride, it can be predicted with the calculations, which can be determined for the Alia region. Then inorganic pollution of groundwater, surface water will be determined with the groundwater also, with the surface water also, we'll determine it. So these are my references. Thank you for listening. Any questions? Yeah.
Thank you so much for your presentation.
Yeah, welcome.
Congratulations. And is there any question for this presentation?
No questions, but I want to say hello to Abdülhafiz. How are you?
Hello. How good hocam. Fine hocam.
Okay.
Hindistan'dayım hocam.
Hindistan'dasın.
Evet hocam.
Oo. Hindistan'dan da katılan var. Bugün Afganistan
Evet
var,
hocam.
Hindistan var. Bayağı
Hı hı.
uzaklardan katılanlar var.
Evet
Bağlantı
hocam.
iyi ama kalite iyi. İnternet güzel.
Güzel hocam. O 3 tane hocam cep telefonu vardı burası hocam. Burada. Eğer bir şey
Tamam.
olursa hemen
Tamam.
öyle yap.
Teşekkür
Bağlantısı
ederiz.
yapacağım hocam.
Başarılar
Çok
dileriz.
teşekkür ederim hocam. Çok sağ olsun hocam. Eyvallah.
So we are going on the last presentation, and it has remained unfinished due to the technical problems. And this presentation's title is Rural Electrification with Solar-Powered Mini-Grids and Standalone Solar System Installations, case of Somalia, prepared by Abdiaziz, Hüseyin Abdi, and Hasan Zorlu. Abdiaziz, can you hear me?
Yes, I'm here. I hear you.
Okay.
Let me share my screen.
Okay. You may start your presentation.
Can you see the screen share? Can you hear me?
Yes.
Okay, thank you again, and good afternoon, all of you. Let me continue my presentation. I'm talking about a solar-powered mini-grid and standalone solar system installations, rural electrification in Somalia. If I continue in here, we have a system, a simple descriptive system. First, we wanted to show the simple principal structure of our system. There will be a standalone. There will be a solar power generator. After that, we will connect what we call a charge controller and the battery. And we will deal the battery, as we know, the solar system just produces electricity during the daytime. So in the rural area, there may be a problem because most of the energy is used in the nighttime. So we use a battery. In the full text, we have described a full what type of batteries we are going to use, and all of it we describe it in the full level. In here, we show the installing system and how to install that simple structure that everyone can use using our structure or our installation wiring diagram. In here, we have implemented our system with two softwares. The first one is BPSys, and the second one is what we call a HOMA, or a hybrid optimization of the solar. We use these two systems and we compare the results, and the result shows that the system that is suitable to electrify in the rural areas of the Somalia, because these two systems uses NASA data for geographical area for the solar radiation, and also we calculated the economic analysis of our system that we use a red screen software and also other different websites that help us to summarize the economic analysis of our system. For conclusion, and our recommendation goes, this paper has offered a general and overall focus on the primary design and the operation considerations, providing the availability of establishing a solar mini-grid in large scale as a case study. The home simulation is helped us to point the feasibility picture of the mini-grid component structure, which hence provide valuable. This study undertaken should be considered preliminarily studying the development of the PV systems on mini-grids in implementation of the rural electrification program in Somalia, and perhaps a parallel can be drawn in other regions in the country with similar valuable characteristics. That's all my presentation. I would like to say you again, thank you for giving me this opportunity, and thank you for listening me. If you have any questions, you can ask me.
Thank you for your presentation.
Thank you also for this.
Is there any question or comment for this presentation? Okay. This is the end of the session 15. Thank you for all presenters for their valuable contributions to this organization. Thank you for participating in this session. Hope to see you the next organizations. Have a nice day.
Have a nice day. We also thank you for organizing this very important congress. Thank you.
Değerli arkadaşlar, kapatmadan önce müsait olanlar kameralarını açarsa bir beraber fotoğraf alalım. Evet. Teşekkür ederim arkadaşlar. Sağ olun.
Teşekkür ederim.
Görüşmek üzere.
Sağ olun. Görüşmek üzere. Sağ olun.
Hoşça kalın, iyi günler.
Size de iyi günler. Sağ olun.